Well, hello. Okay, so getting kind of tired of doing these things. This is number 18, which is Form A. This is number 13, Form B. So I'm just going to give you a couple hints on this one, okay? So you had this reaction and you had delta H. And then the problem, long story short, is asking for delta T, or sorry, the final temperature. So somehow you know that this is going to end in MCAT, okay? But I think probably one of the mistakes that some of you guys made is this is delta H of reaction. So this is the heat released per this balanced equation. Okay, and before you can start doing calorimetry, you got to go from delta H of reaction to Q of reaction, which means you got to figure out the heat released per the amounts that you have in this experiment. So maybe that's where the mistake happens. So, if you go ahead and take the grams of magnesium, convert it to moles, of course, and then please do remember that there's 2 moles of magnesium per 1,204 kJs. Okay, so maybe that might be part of the problem. All right, so needless to say, number, okay, and it's in kilojoules, and I'm going to leave it in kilojoules for an important reason. It's also a negative because this reaction released energy was exothermic. All right, so that's my Q of reaction. That's the heat released for the amount of magnesium I used. Okay, well, once you get to Q of reaction, that's the system. So then we need to change the sign, and that's going to be the heat absorbed by this water and this metal calorimeter that the problem talks about. Okay, so that's fine. Now we can do MCAT. But then you guys start to panic because you're like, what mass do I use? Do I put the mass of magnesium in there? Or, and what specific heat? Is it specific heat of water? How do I work in the metal? So like confusion sets in. So that's why this problem was really testing your ability to apply what you learned in this unit, because it gave you this heat capacity. And the heat capacity is in units of 3.87. Oop, I got a message. Kilojoules per degree Celsius. So the bottom line is you don't have to worry about the mass because we're talking about the metal heat calorimeter, or sorry, the metal calorimeter and the water together. It requires 3.87 kilojoules to raise all of that, the water and the metal together, 1 degree. So folks, you know what? This guy right here takes care of the mass and the specific heat all in one. We're using the heat capacity instead. So then you can just multiply that by delta T and notice that this is in units of degrees Celsius, right? So that cancels out with degrees Celsius and you're left with kilojoules. Okay, so that's the right units that you guys want. Okay, so that's what's tricky about that one is, we just hadn't seen a lot of problems like that. But if you understand how MCAT works, and you understand how units can help you, you realize that, okay, this heat capacity involves both these components. Okay. So if I multiply by the temp, I'm good to go. All right. So then you can just set that equal, to the heat absorbed by the surroundings, and you should be able to figure this out. All right. I hope that helps. Thank you for listening. Have a great day.